This is Sudesh Ashok Dakwe from BTech Civil. I am here to give a presentation on ISE 1 of a subject Elastic Rebound Theory. The introduction, we will cover the basic premises, tectonic stress, elastic deformation, breaking point, earthquakes generation, rebound, and cycle. These all the points of elastic rebound theory, and we will see this. First is the stress, strain, and elastic deformation. Stress is the force exerted per unit area, and strain is the physical change that results in response to that force. When the applied stress is greater than the internal strength of the rock, strain result in the form of deformation of the rock caused by the stress. We can see this in this image. Similarly, the crust of the earth can gradually store elastic stress that is released suddenly during an earthquake. This gradual accumulation and release of the stress and strain is now reflected to as the elastic rebound theory of earthquake. We can see this here, crust at rest. First is the crust at rest. Second image is crust deformation, strain accumulate. In this strain built up and rupture crust causing earthquake. We can see in the third image, and last image, fracture crust fault zone is occurs and strain is released. Causes of earthquake. The tectonic plates are always slowly moving. The tectonic plates we can see in this exam, the tectonic plates and crust this year. And when the stress on the edge overcome the friction, there is an earthquake that releases energy in waves that travel through the earth crust and cause the shaking that we feel. The process of elastic rebound during an earthquake, as the plate try to move the relative to each other strain energy gets built up along the boundaries. When the stress buildup reaches the ultimate strength of rock fracture and release the accumulated strain energy. If material is very ductile and weak, hardly any strain energy could be stored in the plate due to their movement. But if the material is strong and brittle, the stress built up and subsequent sudden rupture release the energy stored in the form of stress waves and heat. The propagation of these elastic stress waves causes the vibration motion associated with earthquake. The region on the fault where the rupture initiates is known as focus or hypocenter of an earthquake. Epicenter is the location on the earth surface vertically above the focus. Epicenter is the location on the earth surface vertically above the focus. Distance from epicenter to interest is called as epicenter distance. Epicentrical distance. Here we see the one historical example of elastic rebound theory. San Francisco earthquake, we know geophysicist Harry Fielding Reid examined the displacement of the ground surface along the San Andreas Fault in the 50 years before the earthquake. He found evidence for the 3.2 meter of bending during that period. He concluded that the quake must have been the result of the elastic rebound of the strain energy stored in the rocks on either side of the fault. Later measurement using the global positioning system largely support Reid's theory as the basis of seismic movement. Conclusion is, while the elastic rebound theory is a useful tool for understanding how earthquake occurs, it is important to recognize that there are alternative theories and common misconceptions that should be addressed. By exploring these alternative perspectives, we can gain a deeper understanding of the complex processing that shape our planet. Thank you.